Hello and welcome to another episode of the Fully Charged Show podcast. Now in this episode, I caught up with Peter Rawlinson, CEO and CTO of Lucid Motors in Newark, California. Now Peter was previously engineer for the Tesla Model S between 2009 and 2012, and prior to that worked at Lotus Cars and Jaguar Cars as it was then known, which just confirms that in this automotive world, all roads seem to lead to Leamington Spa. Now, no question Peter is a phenomenal engineer, but mention the word lucid and it certainly generates some pretty fruity discussion among the EV community. But in this interview, Peter was extremely generous with his time and candor to get into the nitty-gritty and ins and outs of Lucid Motors, and I really hope you enjoyed this discussion. I'm certainly looking forward to hearing your thoughts in the comments. So let's meet Peter, but first, a very quick break.
Love everything electric? Join us live in the South this October and in Australia, London and Canada in 2025.
Peter, you came to Lucid in 2013. Mm-hmm. At that stage it was called Ativa. I've read that you requested a name change because it sounded like a yogurt. At that point in history, at that point in time, what was your hope? What was your aspiration?
Well, I joined a small battery company and big ambitions to turn it into a viable car company, but more than that, to create the most advanced vehicles the world had ever seen. So in 2016, I built Lucid, and we embarked upon creating the Lucid Air with the first prototypes, which were released in late 16. And look, it's if it isn't daunting enough to create a car company from scratch, that bit would be relatively easy. What we're trying to do is far more profound and significant. We're really on a journey to advance the state of the electric car so that everyone can benefit, and specifically through our own in-house advanced technologies mean we can go further with less batteries, and this addresses the key barrier today from widespread adoption of true sustainable mobility, which is the battery cost, its size and weight. And the key to that is increasing the efficiency of the car through our technology.
This efficiency piece I think is so interesting because when I look at, and I've heard you talk about efficiency before, and I'm sure many of the people listening and watching will have the same thought of, this is intriguing because on the one hand, talking about mainstream adoption of electrification, ensuring that electric vehicles can become cheaper, lighter, smaller, etc. But on the other hand, we are talking about luxury EVs. And those two kind of goals and aspirations may seem at odds with each other. But I wonder if you could walk us through how you see those two spheres connecting.
No, you're right. This is the great paradox. Unfortunately, we have to face hardcore economics here. The cost of industrializing a product like a car is inversely proportional to the cost of the vehicle. For example, if you want to make a Rolls Royce, it costs a lot of money, so not many people can afford it. So you need a tiny factory because you're not going to make many, and it's very handcrafted. So there's little investment for making a high-end car. Conversely, if you're going to make something like a Volkswagen Golf, you need a massive factory, high degree of automation, massive investment, but the actual product is relatively affordable. So we had to start with a high-end product, but make no mistake, I think this is one of the biggest misunderstandings there. Lucid is not planning to be a niche luxury player. We're here to have a profound impact upon humankind's transition to sustainable mobility. And the technology we're developing today through our high-end products like the Lucid Airs we have behind us will lead to more affordability in the future, and this is key.
One of the things that you talk about is how important efficiency is, and using efficiency as a way to get to this future of smaller, lighter, cheaper electric vehicles. But what's the strategy for Lucid? Is it sort of pioneering technologies with the aim that that innovation trickles down to those more affordable marks, or actually making a smaller, cheaper, more affordable vehicle yourself?
We had to start with a high-end car because the cost of industrializing a product is inversely proportional to the cost of the product itself. So starting with a high-end product made perfect sense. With the technology we're developing for that product suits more affordable models in the future, we aim to come down to a $48,000, $50,000 price point. Beyond that, I think it makes more sense for us to license our technology for another automaker to make the proverbial $30,000 car.
This has been such a joy researching both my questions for this interview and also for the other episode that we'll have on the channel. Mm-hmm. And it's been so interesting comparing what's happening in the $249,000 Sapphire car and the Air Pure, which those two, and that one I should say is at $69,000, yes. $549 per month leases, all that kind of thing. And it's so interesting seeing those at the sort of, bookends of your product portfolio and seeing the technology that underpins them. And I wonder if you could just, I'm not going to do it justice, you will be able to do it justice, but I wonder if you could share some of the really, really key and core technologies that underpin them.
Well, first of all, I wanted it to be like a ring cycle. The cycle is complete, that the Pure and the Sapphire have something in common. They're both metal roof, pure driving machines. The ones in between have got glass roof options. So you actually distill the product to its purest form in the Pure with a rear-wheel drive driver's machine. And it's got a unique pointy character to its steering. It's lighter, it's very agile, it's an incredibly engaging car. And with the Sapphire, you have the full experience. You have 1,234 horsepower. I made that number up, by the way. Seriously.
I can now see.
So I can go
now
1, 2,
see
3,
what you've
4.
done.
Seriously. As long as you actually quote a number which is less than the actual number, it's legal to make a number up, Imogen, I assure you. But then you have the full experience and you go full circle to this extreme performance attributed car, which at the same time has got incredible steering response. And paradoxically, when I launched the Sapphire to the assembled troupe of journalists, I said, when you drive the Sapphire on the road tomorrow, I want you to drive it slowly. And they said, this guy must be nuts. I said, no, because it's that steering response and that agility and the lane change response. That is the Lotus in me from my Lotus days. That's what I wanted to endow this over £5,000 car with, which seems impossible. So you've got it really a full circle from the purity of the rear-wheel drive Pure to the full-on exhilarating performance of the Tri-Motor Sapphire.
It was, I have to say, we had a go going to 0 to 60 in the Sapphire. It was the most unbelievably and most extraordinary experience I think I've ever experienced my whole life. My eyeballs went funny, these butterflies in my stomach just kept on going and going, and it just felt like this thing could continue to accelerate forever. And then equally, you've got the 69,000 Pure. And I'm sure people sort of make this assumption that, oh, it must be such a reduced version of the Sapphire. And it's not at all. It still has that incredible driving character. You can tell that so much thought has gone into the driving dynamics. But I think what really strikes me is that it's very evident that you as a CEO and CTO really understand these things in a way that we speak to a few execs on the Fully Charged show. And I don't think all of them have the same kind of very deep engineering knowledge that you have. And I wonder how that's influenced some of the decisions within the products.
I think, first of all, look, the company is only as good as the collective intellect. I'm blessed with an assembled group of engineers who are outstanding in their field. So it's not me, but I do think that we're an engineering-led company like no other. I think that is true. And I think our love of driving, of performance driving, of fast cars, and that shows in the product, it's part of the DNA. But we're also a Silicon Valley tech company as well. So it is a very advanced computer on wheels. It's both those things. But it's very much a team effort, this. No one person can create a product as complex as this.
I want to talk about miles per kilowatt hour because we were having an interesting conversation before the cameras started. Now, to set the scene for those listening, the Lucid Air Pure, it has a miles per kilowatt hour range of value of 4.75 miles per kilowatt hour. The 25 model year version will be 5 miles per kilowatt hour. But you actually had something to do with how we talk about efficiency. Can you Take us on the story there.
Yes, well, traditionally, efficiency wasn't measured in efficiency. It was measured in the opposite, the inverse of efficiency, which is consumption. So engineers talked about watt hours consumed per mile. And you're an engineer as well, Imogen, by profession, so you'll understand it. But I think it's really important that we demystify such nuances for the intelligent layperson. I think this is hugely important, and I feel it's almost a responsibility of mine. And I felt that people understand miles per gallon. It's so digestible, but watt hours per mile seems such a weird concept and a construct. It's very difficult to get your head around it. So I started talking about miles per kilowatt hour instead, because I felt that was part of the demystification of EVs. And fascinatingly, it's almost a 10-to-1 ratio. You get an average petrol car does about 30 miles to the gallon. An average electric car will do about 3 miles per kilowatt hour. A really bad petrol car will do about 15 miles to the gallon. And a really bad EV will do about 1.5 miles per kilowatt hour. So it puts in context our pure getting 5.0. It's just like having a genuine 50 miles to the gallon petrol car. And I think this is really important that people can digest this weird and wacky world of EVs. And that will lead to less suspicion, less concern, and a wider adoption, I think.
Do you know, I do think that's so fascinating because, and we were talking before, that so often people are obsessed with range. And in order to get increasing amounts of range, if you don't prioritise efficiency, that means just more and more batteries, which in itself is not a very efficient thing to do. And putting miles per kilowatt hour front and centre really pushes and forces the industry to have it something that you wear as a badge of honour, I suppose.
I don't think anyone was really talking about this or even thinking about it until we really promoted this. If you wind back to 2016 when I built Lucid up, it was a generally held belief that you couldn't improve the efficiency of an electric motor. It's so much more efficient than a gasoline counterpart, a petrol counterpart, and that's true, but there was this wide held belief that range was a function of just how many batteries you stuffed in. And I even see today reviews of cars, they say, well, the range is lousy, they should have found more room for batteries. No, they should have had a high-tech solution which would have gone further with the batteries they've got. And you know, everything gets better if you can go further with less batteries. But it's not just the cost of the batteries, it's the damn weight. I mean, it's shocking, the weight of a battery pack. And then the package space that those batteries take up. One of the reasons we've got such a spacious car on the inside, and it's really deceptive. This car is smaller than its counterparts on the outside, much more spacious on the inside, with exceptional range, because we've got fewer batteries, and the batteries we've positioned and sculpted them around the occupants. This is critical.
I want to come on to the motor side of things, because this is something that I watched one of your tech talks around how you've created this single drive unit and actually this whole systems level engineering approach to think, well, how do we do things like consider cooling at source rather than just creating a thing and then having to bolt on a cooling system on top of it. But I wonder, how did it take much to transition the whole organisation around that way of thinking? Or were people largely there to create this super efficient thing?
One of the luxuries you have as a startup is you can choose your team. So it was, I think, the most important role I had was attracting the best brains in the world to join us, a little company which in all probability was going to go bankrupt. Come to California, bring your family, and come and join me. By the way, I'll probably go bankrupt, but if we don't, we're going to create this most advanced technology. Either way, you're going to have a blast. And if we can pull this damn thing off, it'll be a wonderful thing, a wonderful experience. So I think that was the key. Again, it's accruing that collective intellect that can execute this.
And with that incredible collective of people, I see that you've recently announced that you want to hit 6 miles per kilowatt hour.
Yes, well, that's. We don't know if it's possible. I didn't think 5 miles was possible a few years ago, and even last year I didn't think we'd get 5 this year. I thought it might be late 25. Even earlier this year, I thought it was going to be. We've actually managed to achieve it earlier. So the holy grail is 6 miles per kilowatt hour. It's very close to 10 kilometres per kilowatt hour, so you can go fully metric with that. It's a very strange fudge, miles and kilowatt hours. But yeah, that's and I've actually have a project here, which is like Project 6 or Project Chwech in Welsh. That's really looking at, can we move, how far can we move? Can we get 5.1? Can we get 5.05 first? And what would it take to asymptotically approach 6 with a viable product? Because it's one thing if you make a carbon fibre, artificial prototype and run it downhill to the coast. Yeah, you can achieve crazy hypermile numbers. But all these numbers I'm quoting are on the Environmental Protection Agency EPA numbers. So when people say, oh well, I can get 5.2 when I drive my certain car, well, yeah, we can all do that. I could actually get a minus number because I could drive downhill. I could be on regen all the time, and I get actually a negative number. It would be a very artificial construct, but easy to achieve.
So what we also need to find then is that, if you do hit the 6 miles per kilowatt hour value, what's the maximum that somebody could get? Can they get sort of 10, 20 miles per kilowatt hour? Because there will be the people that will say, okay, well, let's find the perfect weather conditions, optimize the air conditioning or whatever inside, and largely drive downhill.
Yeah.
So,
It doesn't interest me that much because it's so artificial. What I want to do is solve real world problems. There are so many interactions here. Tyres are critical. They have a huge bearing on range. Tyre pressure does as well.
Yeah.
Wheel bearings have a huge influence. It's surprising. So one of the compromises is on-centre steering response versus range. And that can make like 30 miles difference. It's unbelievable.
Yeah. There will be people watching and listening to this who will be like, okay, efficiency, I get it from a sedan perspective because they lend themselves to that swoopy, less than 0.2 coefficient of drag.
Yeah.
But the next product in your portfolio is an SUV, which admittedly, I think the drag count of that is 0.24, which is still really, really impressive.
I wish it was a little bit lower. We'll see.
Still time.
Not happy with that.
But I wonder how that as a product squares with ambitions for super efficient, super lightweight vehicles.
It doesn't. I mean, we're not going to get the same levels of efficiency with Gravity, Lucid Gravity. We're probably going to get about we're going to probably get about 3.7 miles per kilowatt hour with that on an EPA cycle. So it's not going to be as slippery as a Lucid Air, and it's not just as an aerodynamicist. I mean, it's not just the CD. It's not just the shape. It's the size, which is the A. So it's CDA, which creates that form drag, as you know. So you really, even if you got a really good CD number for that for the SUV, it's just bigger. But it's not all aero though. There's so many other factors in this. Tyres are huge. As I say, it's just like brake drag is quite a factor. There's 1,001 things, and then you've got real world things like the cooling ducts. We've got this active cooling vents which lead to a vortex induction cooling system on Lucid Air. And that gives us a real world advantage, which you don't really see in an EPA test.
Now I'm going to ask you a question, which you've kind of alluded to some of this already, but as we know, starting any company is challenging. Starting an electric vehicle company is very, very, very challenging. I wonder if you could take us through that journey of some of the maybe slightly hairier moments. Oh yeah,
so I joined a little more than a mom and pop shop with a battery company, and one of my first jobs was to really get some funding, a Series C funding, and I was instrumental in securing that $200 million, which led us on our way. But we got through that pretty quickly, and we were nearly bankrupt so many times. At one stage, I was about 23 hours away from bankruptcy.
Wow.
I got a significant loan from the Far East, and I would have been personally bankrupt if that hadn't come through. So I actually faced personal bankruptcy on more than one occasion. And I thought, what am I doing this? I'm just an engineer. Why am I the wrong side of the world in doing this? How have I got myself in this pickle? And then I put a whole bunch of my life savings into this company. But it's been a blast. And what really saved us was two things, and they're linked actually. We went racing. You know, not often can you say that going motor racing saves a company. Yeah. So in one of our darkest periods in 2016, before we launched the car, and all my engineers were stretched, and we were a tiny company, just a couple of hundred people, and we were trying to do this impossible thing, get a first prototype of Lucid Air out. We want to launch the company as Lucid. This is late 16, and I went to the FIA in Paris and tendered for the battery pack, which was going to power the World Championship Motorsport EV Championship. And we won that tender. And I came back to the team in California and says, hey guys, we're going motor racing. And it's like, he has really lost it. But there was method in my madness, because I knew that there's this whole phalanx of new EV startups. And most of them are not real. And we had something very, very special. How could I prove it? I didn't have the money to get the car into production. I needed a proof point of our technology. And we actually powered the World Championship for 4 very successful seasons. And that turned out to be the proof point for, and a key sort of tick in the box when the Public Investment Fund of Saudi Arabia came and rescued us and really changed everything. And that was the key enabler, that they, amongst everyone else, saw the true value in us. They saw that we were real. It was totally legitimate. They saw that it was world class. We needed the money to put the car into production. And this then enabled, the money came through in the spring of 2019. And late that year, we actually dug the foundations in December 19 for our factory in Arizona, the first state-of-the-art factory for EVs in North America. And then, of course, through COVID, we built that factory up in record time, and late summer 20, we were able to build some of the very first prototypes on a pre-production line in that factory. And then that led to us going public in 21, and late 21, in October, we actually sold our very first cars. And that's from getting the money in early 19 to in production late 21. I think that's a world record. The pace we've operated has been really beyond. I don't think anyone realises just how accelerated this pace has been. And then through 22, we had a logistics challenge in the company where it was very difficult to us to make cars because of the quality of the parts that were coming in. And I wasn't doing 100 hours a week, I was doing 110 hours a week.
Oh my goodness.
And I always say, you can do 100, that's okay. It's when you go over 100, that's when it starts getting a bit mental. And you can't do that forever. But through the latter part of 22, because there were 2 shifts, so I was having to try to cover it 17 or 18 hours a day. And we got through that, and late 22, we were able to really say, right, we can manufacture. Now, since then, the constraint has been really the market, so how many orders we get. But we haven't got a production problem.
Yeah.
We can make them.
So I have to say, because I think once you have both plants online, the one in Saudi Arabia and the one in Arizona, you will have capacity to build 240,000 vehicles per year.
Exactly.
You're a little bit way off that at the moment.
Totally, yeah.
What do you think needs to happen to sell more vehicles? What would really help accelerate that for Lucid?
A couple of things. It's brand awareness. There's a lot of people who've still not heard of us. And then there's also many people can't get their head around, why should I have this? It's much safer to go with 3-pointed star, a storied brand.
Yeah.
And not many people will intellectualize, actually this is a better product. So I think there's got to be those who dare, those who are not going to take the normal path. It's, they recognise and intellectualise this is a superior product, and actually speaks volumes about them as a customer, as an owner, that they know. If you know, you get a Lucid because it's better. And so that word needs to spread. That's the first thing. Then we need to get Gravity into production. That's going to have a much bigger market appeal. That's the car that all America yearns for.
Yeah.
So I think that's the thing. But we have come off. We came off a record quarter one. Quarter two was 70% up on sales over Q2 of last year, and we delivered just over 4,000 cars in 22. It was up nearly 50% to 23, 6,000 cars. We haven't disclosed how many we plan to deliver, but we have said we'll manufacture about 9,000. So that will be up a 50%. So we've got 50% growth in a brutal market where everyone else's numbers are down. We're outselling the core competitors from Germany. And for quite significantly, we're outselling Porsche Taycan, Mercedes EQS. We're outselling Audi e-tron here in the US. So I think we're on the up. And Gravity, there's a huge interest, latent interest in that.
So the Pure, I think, is eligible for Inflation Reduction Act tax credits when it's on a lease.
Yeah, well, the products are on a lease. There's a what you could say a little bit of a loophole with the lease.
And how helpful has sort of initiatives like that been? And what more is required from, I guess, a more systemic level to help push EV adoption?
Yeah, so I'm very appreciative of the US government's the Inflation Reduction Act, the IRA, and which has helped us in certain areas. But what I'm lobbying for is greater appreciation of the true value that technology has to play. There's a perception that all petrol cars are bad and all EVs are good. It's like, fruit is bad, chocolates are good. So I might have got the wrong way around. But there's this binary perception of the landscape. And that doesn't reflect reality. So the current regulation set is incentivizing the number of batteries you put in the car. The more batteries you put in the car, the more support you get from the government. So this is incentivizing not gas guzzlers, they're electron guzzling EVs. So if you look at some of the products out there with Gravity, we're anticipating around a 440 mile range. It probably have about 120 kilowatt hour pack.
Yeah.
There are competitors out there with literally double that pack size, 240 kilowatt hours, and they have to be double stacked. They weigh an inordinate amount. It actually reduces the payload capacity. Gravity is a 1,500 pound payload because it's not carrying so many batteries around. There's room for your feet and legs, so the roof can be lower, and then it's a benevolent circle. And remember this, if you add 10 batteries to a car, 10 cells, you're going to need to add an 11th to compensate for the extra weight of the 10 you just put in. That's how bad this vicious circle is.
And so actually, what you're really saying is that to help drive this adoption, it comes back to that efficiency point and how that's prioritised as a metric.
Can you imagine 120 years ago, and the roads were opening up and the horseless carriage was sort of taking the place of horses, and the government incentivised a gas guzzling motor car. The more gas it uses, the more we'll incentivise you. No, they should incentivise more efficient gasoline cars, and I'm lobbying strongly for that, and it's our technology that enables that.
So I need to ask you about licensing technology and drivetrains, because it's very evident to me, having driven both the Sapphire and the Pure, that they are filled with so much character. And is there any concern that if you do license that technology, that you're giving some of that character away? How do some of those things sort of work? I know that, for example, there's I think you have a deal with Aston Martin? Yes,
we announced a supply contract with Aston Martin last year, which at the time was worth at least $450 million, so a significant sum, and that's to supply Aston Martin with our Sapphire technology, which will see their hypercar future for the next decade, and they're a wonderful partner in this. And I think that, I hope it's just the first of many. Certainly it's opened the door for dialogue with other automakers. And I see a profound potential here for us to. With Aston, we're going to supply the parts. I think if it was higher volume with a less affordable car, we'd have a licensing deal so that the partner would actually manufacture the parts, maybe in the Far East, wherever they are, and then you'd have we would have a royalty for each time the software enables that unit to work. It would be like there's an Intel inside your laptop, there's a Lucid inside their car, and it would be like we'd operate like a software company. Like if you've got Microsoft Office, it flashes to your laptop, and Microsoft, thank you very much, receives a payment. So I that's the vision for the future. But some people think we could just do that. We just, that could be the business to be in. No, we'd then be a supplier, not a true technology company. The shop window for such products is us putting them in our cars first and foremost, and that's where the characterization comes in, and that's where I'm not worried, because there's a lot more to the way we put the whole car together, the space concept, the platform architecture, the driving dynamics, the tuning, the DNA of the product. It doesn't scare me at all. Bring it on. If we can't face that competition, well, we shouldn't be here.
Do you think a legacy OEM would have been able to create what you've created?
I'm going to say something controversial here.
Oh.
Resoundingly yes. Any legacy automaker could do this tomorrow.
But why
there's a narrative that they can't, but there's a reason why they are not doing so, and I'll give you the two reasons. In order to do this, you need to appoint someone to lead it who is capable of doing this, and that's tricky because there's not many people who are capable of doing this. Because you need a breadth of technical and kind of business commercial acumen to do this. You can't, and so you need one person who can do it, but you need to make them totally 100% empowered to do whatever they have to do. Those are the two steps. You have to, and that's why it only happens in a startup, because you get someone who sort of leads or founds the company, and that person has the authority, and I'm fortunate to have this here. And actually, in my former life at Tesla, when I was chief engineer on Model S and Model X, to be fair, my boss then, he really did empower me to do Model S. That's how Model S happened. If I hadn't been truly empowered, it would never have happened. I was able to personally recruit all the great engineers in the Tesla Model S team when I set up vehicle engineering at Tesla, and I personally interviewed and chose the most brilliant people I could attract to that company. And really, that's what enabled Model S to happen. A lot of people said, well, Tesla doesn't have any experience at doing cars. Well, a company hasn't got any experience. It's the experience and expertise of the employees. That is the experience of the company. And it had the greatest engineering team on the planet. And I'd like to think we've done that and really taken it to the next level here. And a lot of my old team at Tesla came across. Hundreds of people have come across from Tesla and joined Lucid.
So I imagine with that truly phenomenal experience that you had at Tesla, you were able to reflect on that and think, okay, well, here are some of the brilliant things that I want to pick up and emulate at Lucid. Being empowered, having a fantastic team, being part of that. But I'm sure there were other things that you thought, I'm okay to take a different approach at Lucid.
Totally.
Do you remember any of those?
Yeah. I mean, one of the things I wanted to do with Model S, but I didn't have the opportunity, I wasn't allowed to, was to have a more sculpted battery pack that would make a better occupant package. That's why the seating position of Model S is really cramped, and it wasn't my decision. It was so I felt really constrained. I knew we could make a better car when I was there. So it wasn't. I wasn't stretched. I was constrained, and it was. I was really frustrated that I wasn't allowed to make it better than it could have been. So this is the result. This is what Model S could have been.
This is what happens when you're unleashed.
Yes, yeah.
I also need to ask you about China, because once your vehicles are out in the world, once all of the technology can go into various teardown departments in various different OEMs across the world, people can start to see, perhaps we could do this or elements of this ourselves.
Totally.
Are you worried?
There's always that risk. Yeah, absolutely, because patents count for nothing in this sort of globalized world. When Model S was launched, we thought that it was only going to be a year or two before it was totally copied and cloned. What happened was that elements of it were cloned independently, and it wasn't successful. And because there was a big picture package thinking to that car, and if you copy the lot, it's pretty good. You try to pick out elements, because it was really architectured. I architectured it in a way that was very integrated, super integrated. Now, the same is true with this product. It is so three-dimensionally integrated in its thinking that elements could be copied, and they might get an incremental advantage. But this is really a great example of where the whole is greater than the sum of the individual parts. And I can give you an example of that. When we were doing this car, there was a general consensus that, electric motors and drive units are smaller than gasoline. I've gone American, I should say petrol, than petrol engine counterparts. And that is true. And everyone was saying, well, there's lots more room to play with, isn't that great? And I thought, if they're smaller, how small could we make them? We make them really small. So let's see how far can we push this miniaturization and what was the advantage of that? Well, we can make a car smaller on the outside and bigger on the inside. You're Brit, Doctor Who's TARDIS. That was the TARDIS was yes, yeah. It's a TARDIS. That's what I wanted to do. So it's smaller on the outside than the Tesla Model S. It's shorter, narrower, and lower, but it's got more interior space than a long wheelbase S-Class Mercedes. So we really pushed the envelope of the package out with the occupants within the wheelbase. To do that, we needed ultra miniaturized powertrain to make it work. We didn't have that. So I bet the house, and this is where I could never do this at a car company, because I bet the house on, right, we're going to design the car as if we've got this new technology, and you lot are going to develop this new technology that's going to go into this car that's ready to receive it, but if you don't successfully miniaturize it, the car's not going to work. And so we have this incredible parallel run of the powertrain team, and I empowered them to work collectively as a motor transmission inverter unit. I want a single system, a single unit. I don't want bolt-on gearboxes like everyone else is doing, which is terrible. And we created this single element, which is truly world-class. And we packaged the car for that. And that's one of the reasons we got the largest frunk in the world amongst everything else. So, and we even designed from the outset the car as one motor, two motors, and three motors. So that's why I was able to do Sapphire Project really very low cost. It was a very economical project to do because the car had been designed for the three motor installation from the very get-go, whereas others have had difficulty trying to create a tri-motor version of their cars because they can't get it to package and fit inside the architecture, whereas ours was conceived that way originally.
Do you know, I have to say that when you look at the front, which 283 litres, 3 times bigger than the Tesla Model S, and it's such a flex. It's such a way of saying, we have so much room in here because we have the most efficiently packaged vehicle in the whole world.
That's true.
Now, I watched your tech talk on the motor, and there were a couple of things that struck me. First of all, I'd recommend it to anyone who's watching this or listening to this because it's such an in-depth, detailed analysis of how that thing came together.
Thank you.
But secondly, you're very, very good at kind of boiling and distilling maths down into the easy maths. You did it earlier on with,
I'm good at the easy math.
But it's such a useful way to make the maths accessible to people who are maybe a little bit rusty with their maths. You did it earlier with, 3 miles per kilowatt hour versus 30 miles per gallon, factor of 10 as a general rule of thumb. And when you put those two things together, this ability to go into such detail on, the motor unit in the tech talks and to make the maths really easy for lay people, it tells me that you adore engineering, that you are such an engineer's engineer. And I wonder if you could just describe what it means to you to be an engineer. And especially thinking about anyone who's maybe considering this, aged 16 or 17, as a potential career?
Yeah, well, it started with a love of making things. The first things I designed as a design engineer were my own toys, so my dad could make me my own toys.
No way.
And he actually made them for me in Wales in his shed, and I'd draw them out how I wanted them, and he'd make them for me. So I was designing and making things from a very early age, and I think it's that love of woodwork. I've done a lot of stonework, and I was a reasonable stonemason at one stage.
No way.
Yeah. And my passion for just making things, reasonable welder. I've got my own fab shop in the UK, composites, and I built my own house in Wales, and I built my own car. And so all of this actually emanates from me building my own sports car many years ago, which led to Lotus hiring me because it influenced the Lotus Elise. Elise was very influenced by the car I designed and built for myself. And I became chief engineer at Lotus as a result. It was a very happy outcome. And of course, Lotus is a consulting company, and I won a project in the US to design a lightweight aluminium structure in California. And it was a shootout between Lotus Engineering, Porsche Engineering Services. Sorry, Porsche, I won that one. And I headed out to California for the first time in the 90s as an engineer at Lotus Engineering. And I got to know people in California, and that's how I got offered the job at Tesla, because people knew me in California. Otherwise, it would never have happened. Yeah. And because of that, I was able to have the credibility to raise money for and build what became Lucid. So there's a lot of luck. You need three things. You need a modicum of ability. You need to work crazy hard, but man, do you need that luck. But I think the key is to do something that you love. You can't beat that, because you'll never work a day in your life.
Apart from those 110-hour weeks that maybe probably felt a little bit like work in those weeks. So, given everything that you know now, if you could go back and whisper in your 2013 self's ear, what would you say?
Oh, gosh. Well, I could never have imagined the journey. I just think, I think sometimes we're blessed. We're blessed that this is possible. It's a curse as well, because I think it's very important that we do this and grasp this opportunity in time. I think that mankind faces a profound, I'm a bit off track to your question here, but I'll keep going. I think we face a profound challenge to the environment. I really do. I think that we need to make a lot of change our ways. Mankind needs to change its ways. Tell me about it. And mobility is one. If we don't generate the energy sustainably, then EVs are not going to be that impactful. But I'm a profound optimist that others will do that. We can do the car bit, but we need to advance that. And I think there's this, I thought when I started engineering cars so long ago, I thought that I was born too late, because I thought all the good stuff happened pre-war. And now I realise I was born too early, because let me tell you, the good stuff is yet to come.
Well, I think that is a absolutely perfect note to end on. So thank you so much for sharing your story with us today.
My pleasure, Imogen.